In this lesson, we're going to look at updating our output mapping layer to include some safeguarding for simulation purposes. So you might remember way back at the beginning of the course when we started looking at the input mapping layer, we looked at providing simulation functionality where we can choose where our inputs are coming from, whether they're coming from the real world or whether they're coming from the simulation layer. If I just jump over to the input mapping, we can have a look and remind ourselves of what that looks like. But what we're doing in the output mapping layer is effectively ensuring that when we're in simulation mode, we can't drive any physical outputs. So here we have things like our map valves, and we're interested in this simulation mode, seeing if that is active. Because when that is active, we're picking up our information from this simulation data instead of picking it up from these actual, these inputs here. So we're simulating the IO open feedback, IO close feedback. And if we're simulating that feedback, what we don't want to happen is our actual control system send that to the output. So, or respond to inputs by setting outputs. That's not what we're trying to achieve. We're simulating. We just want to know that the data for our asset has the request to open an output or to action an output, but we don't physically want that change to happen. This is really easy to achieve. So all we're going to do is add in a switch basically that says if you're in simulation mode, then action this one item and then stop. So if simulation data dot, and then down at the bottom here, simulation mode, then, and I'll just end that end if. So what we're going to write is temp int, because we're going to use a fill command, and that returns a value on status in the form of an integer. So temp int equals fill. And then if I open the brackets and press Control Shift Space, that will populate the interface for me, so I don't have to choose from the list or type it out myself. And we'll call this one 0 because I want to fill it with zeros. We'll come back to this because I need to populate this first before we use it. And then if we use a pointer, so p hash for a pointer, q0.0, saying that we are going to point to the first output address, and then we want it to be word, and then 50. So we're going to point at the first output address and fill the first 50 words with 0. And we're not using anywhere near that amount. We can see if we go to, if we go to PLC or program info, you can actually have a look at the assignment list, is it? Yeah, assignment list. You can see how many or what memories you're using for input and output. So we can come down here and we can see that these are in bytes. So we're only using 9 bytes at the moment, or there's only 9 bytes available for us to use at the moment. So by us filling with 50, it's definitely going to make sure that none of the outputs can be set. I'm fairly certain as well that even though there's not 50 assigned, we can still fill with 50 and it will just truncate. It'll be interesting to see what result we get at the end, but I'm fairly certain it just truncates. So first thing we need to do is to create our local temporary for the integer to hold the status value. And then here I need to define what 0 is. So 0 is going to be an integer as well. It could be a byte, it could be anything. We're just using it to pass 0 basically. And then I need to set 0 to a value. So 0 equals 0. Now the type of fill command that I'm using doesn't work with optimized data, and because every block that you create starts with optimized data enabled, I now need to come into my output mapping layer and change the type of block to a non-optimized block. To be honest, I've spoken about this before. When it comes to optimized block access, I tend to turn it off anyway. I don't see the great benefit in it. I understand about the whole interface updating and things like that, that you can reserve memory, but with a properly laid out program and some management around your data, reinitializing data and restoring from a snapshot, in most cases can be done on a live plant anyway. So, and the trade-off for optimized data is actually a slower CPU scan. So I'd rather have the speed and manage my data accordingly. So any reinitialization on a single block level is manageable. Once you start changing UDTs and things like that, it doesn't really matter that you've got optimized data. You're changing so much that it would be beneficial, if possible, to ensure that your PLC is in a state where you can make a mistake, where you can stop it and things like that. So make sure your process is tolerant of that stuff. So yeah, you can use optimized anyway if you want. There are other ways of achieving what I'm doing now, but I like unoptimized data where I know where my data is and I can manage it in the way that I feel is appropriate for what I'm doing. So that's how the fill command is being used. And then just to round this off, if I simply put a return in here, then that's going to return out of the current block. So if we're in simulation mode, we set 0 to 0 to give it a value, because if you use a temporary without anything assigned to it, it can actually have any sort of data in there under certain circumstances. So always initialize your temporaries if you're going to use them programmatically. And then we use a fill command storing the results in this temp int and filling all of this pointer system here with 0. So if I go ahead and download this to the PLC now, we can now see that our code is doing what we need it to do. And because we're in simulation mode, we're running this section of code and returning at this point here. And we know we're returning because none of this logic down here has any monitoring variables. And there's no reason why it wouldn't have any monitoring variables unless we were returning early. So now that we're in simulation mode, we have safeguarded all of our outputs. And just to demonstrate, if I try to set this particular output to anything other than what it already is, it will just get set back to 0. So if I was to jump to a watch table, which I can find here, and put in S3 channel 0, which is our output command, and I try and change that to a true, we monitor, it's currently false. If I execute that, you can see that it goes to true and then goes back to false. And that's because the output scan is setting it back to false because we're in simulate mode. And all that is ensuring that if we are in simulate mode, or if you're finished with your office commissioning or wherever it is that you're simulating stuff, and then you move your project or PLC to the actual site that you're going to work on or into the process that it's going to control, that you don't start actually operating outputs whilst you're in a state where the real inputs aren't being read, because you could cause damage, you could cause injury. It's just that safeguard to make sure that your logic is doing the best it can to ensure that if somebody makes a mistake and leaves it in simulate mode, that you don't control physical outputs. Now, by all means, there might be cases where you actually do want to control the output because you want to control the input and see what the real output does. And if that's the case, then when we come back to the output mapping layer here, you can modify how this is set up to only include certain outputs. So you could move this this one here, for example, into this. So if I just was to show you what I mean. So that, for example, would mean if you're in simulate mode or simulation mode, you would still fill all your outputs with 0 first, but then you would update this one particular output only to say, I want you to actually action this output. and you can give yourself some control over which ones are then allowed to update in simulate mode and which ones aren't allowed. And really this layer is all about being able to have that flexibility without changing the main project code.